Hello everyone, welcome back to this lecture on derivation. So in the previous lecture we saw how derivation takes place. So we start with a non-terminal and we expand this non-terminal using the grammar rules. There are two ways in which you can do this derivation. The first is called leftmost derivation and the other is called the rightmost derivation. So what is the difference between the two? Let's see. So here you can see this is one derivation. E derives E into E. This is our same example. So next what I do, I use another step. I replace ID by E, E by ID. Then I replace ID by, I think it was a 5. Okay, so I have a 5 here. Then next what I do, I replace E now. Then I replace E with E plus E. Now if you notice the pattern, at every step I have replaced the rightmost non-terminal. So here I have replaced E, which is rightmost. Then next I have replaced ID. Then after replacing ID, I am left with this E, so I have replaced this E. Then I have expanded E plus E. I have replaced this E by E plus E. Now if I continue in this manner, you will see I have E plus, now I will replace this E by ID. So as we go on with the replacement or with the derivation, I will be left with, say I have 4 here, and now again the derivation E I will replace by ID, and ID I will replace by, let's say, 3 plus 4 into 5. So in the entire derivation process, we have replaced the rightmost non-terminal. At every step, we are replacing the rightmost non-terminal. Okay, as you can see here. So a derivation where you are always replacing the rightmost non-terminal, this is known as your rightmost derivation. And the other is your leftmost derivation. So in that case, you are deriving or you are replacing always the the leftmost non-terminal. So if I just clear this and we start again. So I will start with the same start symbol. So E into E. Now instead of replacing this E, I will replace this E. So I will replace it by parenthesis E. Okay. Then this I will replace by E plus E into E. Then I will replace, now I have 2, so I will replace the rightmost one. The leftmost one. So E I will replace by ID. E into E. Then ID I will replace by 3 if I'm correct. Okay. Then next I will replace this E by ID. Okay, so 3 plus now ID, I think it is a 4 here. This is multiplication. E plus 4 into, now E I will replace by ID, and finally into 5. Now if you notice at the end I have got the same string. I have derived the same string, 3 in plus 4 into 5. So but the steps or the order in which the production rules were applied is different for both the derivation. So one is called a leftmost derivation and the other is called the rightmost derivation. Okay. So these are the two types of derivations that you can have. Next, let us look at parse tree. So what is a parse tree? So a parse tree is just another way of writing your derivations. That is, it is a parse tree, it is a labeled tree. Okay, labeled because you can see in these two examples, this is a tree and each node is given a name or a symbol or it's a label. Now in this tree, the interior nodes are labeled by non-terminals. All the interior nodes you can see are labeled by non-terminals. These are your interior nodes. All right. So these are labeled by non-terminals. And the leaf nodes, all the leaf nodes you can see are labeled by terminals. These are all leaf nodes. They are all labeled by terminals. Okay. So we do the same thing, that is as in derivation. So we expand, we start with a single non-terminal and then we expand. So E I will replace by E into E. This is our other example, that is 3 plus 4 into 5. Okay, so I have expanded. Now here I may have also a leftmost derivation or a rightmost derivation. That means I may choose to expand this next or I may choose to expand this next. Okay, so if I choose to expand this, then it will be a rightmost derivation, and if I choose to expand this, it will be a leftmost derivation. So let me follow the rightmost. So E I will replace by ID and ID I will replace by 5. Okay, then so it was like this. If I give a number to each of these, let me do this. E is replaced by this, then this E is replaced by E plus E. Okay, then I replace this with ID and then here I get a 4. Then this I replaced with ID and here I get a 3. Now if you see, if we look at the labeling, so first I started with this, then I expanded 2, then I did this 3, and then I got this terminal symbol. Okay, then I went to, this is the 4th expansion that I did, this is the 5th expansion that I did, this is the 6th expansion that I did, then this is 7th, this is 8th, and this is the 9th. So here in this parse tree, we have a we have a rightmost tree, because we are replacing the rightmost element, non-terminal. Same way you can have a tree which is doing the other, that is the left derivation. So again I can have E starting with E into E. So now instead of expanding this, I will expand the other one. So this I will have E parenthesis. Okay, then this I will expand it as E plus E. Then I will expand this as ID and this as 3. Then this E I'll replace by ID and then here I get a 4. Okay, then I go to this E. Okay, so I get an ID here and I get a 5 here. All right, so now my order is like this: 1, then 2, then 3, then 4, 5, then 6, then 7, then 8 here and 9 here. So you can see the order in which we are expanding is different for the two parse trees, but the string is the same. Okay, so this is the concept of a parse tree. Now if you can recall, a parser generates a parse tree. Given a string, it generates a parse tree. So the parse tree that is generated by the parser must be unique. So I cannot have two parse trees like this parse tree and this parse tree for the same string. That is why the grammars that you have has to be modified. The grammar that we have used here has to be modified so that whatever be the string, it will always give you a unique parse tree. So you will have only one single parse tree given a string. So a grammar which does not follow this, which gives you more than one parse tree for the same string, this is known as an ambiguous grammar. So we'll discuss that in the next class.